right, part 11. We're going to do 55, and then we're going to backtrack to number 48. No, backtrack to number 49, just because that one's going to take us a little bit of time. All right, so number 55, we have, this is part 11, and it is number 55. So for number 55, we have vector v, and it's negative 8i plus 9j plus 12k. And we want to write this, I want to find the direction angles and then write the vector in the magnitude and direction angle form, which pretty much means polar form. So I need to find direction angles first, which means I need to find the magnitude of v. So that's going to be a negative 8 squared plus 9 squared plus 12 squared. So let's hope and pray that that ends up pretty. So we've got 64 plus 81 plus 144. Gives me 17. Okay, so my magnitude is 17. So my direction angles are going to be found by writing this as a quotient. So I'm trying to figure out which way they want you to do it first. Give me 2 seconds. I'm looking at the answer key. Which way do we want to do it first? We want to do it in direction angles first, which means we have an alpha of, all right, so my alpha angle is going to be negative 8 over 17. My beta is going to be a 9 over 17, and my gamma is going to be a 12 over 17. And in order to find our direction angles, we're just going to take the arc cosine of all three of these. Okay, so the arc cosine, my alpha is going to be the arc cosine, stop it, cleared for the love. All right, the arc cosine of negative 8/17 gives me 118.07 degrees. Okay, the arc cosine of beta, so arc cosine of 9/17 gives me 58.03 degrees. And the arc cosine of gamma is going to be 12 over 17 is 45.0, actually 45.10 degrees. Those are your direction angles. Now we're going to write it in terms of direction cosines. So vector v is going to be the magnitude times the cosine of alpha plus the cosine of beta on I, cosine of beta on j, plus the cosine of gamma on k. Okay, that says cosine 45.10 degrees on k. Okay, so those are your direction angles, and this is in terms of magnitude and cosines. So now we are finally back to our final one, good heavens to Betsy, which is number 48, which I've been skipping simply because we have to come up with a sinusoidal curve. So this is number 49. And I am told that the number of hours of sunlight in a particular town on the winter solstice, so the winter solstice is 8.22 hours. And on the summer solstice, I do not like this pen, is 11.11 hours. Okay, and I'm supposed to fit a sinusoidal curve to this thing. Okay, so A is find a sinusoidal function that fits the data, and B is use the equation from part A to predict the hours of sunlight on June 5th, which it says 5 with an ST, whatever. Okay, so first of all, our winter solstice occurs either June 21st or 22nd, so we're going to say June 20th, and the summer, or the winter, what piece of trash, this is June 20th, and this is December 20th. Okay, and so we're going to map this thing. The bottom of this curve, if it's a sinusoidal curve, is going to be at 8.22, and that's on December 20th. So what we have is, instead of starting at the origin I know that this thing is going to bottom out at 8.22, and it's going to be 11 days shy of New Year's Eve. So this is at negative 11 days. I bottom out at 8.22. Okay. On June 20th, which is going to be the halfway point between the year-ish. So I've got 31 plus 28 plus 31 plus 30 plus 31 plus 20 days in June. Gives me 171 days. So I did January, February, March, April, May, and then the partial amount of June is at 171. So at 171 days, I've got 11.11 hours. So I'm going to go from here, and I'm going to curve up to here. And I want to fit this curve. So first of all, what's my amplitude? My amplitude is going to be the halfway point between these two things. Okay, so the amplitude is going to be 11.11 minus 8.22, which gives me 2.89. Okay, so the halfway point is going to be half of that. So divide that by 2, and I get 1.1445. So from the halfway point, I go up 1.445, and I go down 1.445. So my amplitude is 1.445. What is my vertical shift? Because that's going to be another easy one to find. Okay, so if I find my vertical shift, well, the middle point should be at 0, 0, 0. So where is my middle point? My middle point went from 8.22 plus 1.445. Gives me my middle point, instead of hitting at 0, 0, will hit at a vertical change of 9.665. So I went up 9.665. So what that means is from here, I went up an additional 1.445, or from here, I went down 1.445. Either way, my center point is at 9.665. So what's the period of my function? The period of my function is going to, it's going to change. I mean, it's going to repeat every 365 days. So I know that my period is going to be 2 pi over b, and my period is 365 days. So every year it's going to repeat. Okay, so flip-flop, and I get my period is going to be 2 pi over 365. Okay, the last thing I need to do is the phase shift. And there may be a rounding error in this, which is why I left this problem till last. So what is my phase shift? Well, I know that this thing repeats itself, and what I want is to find out where this point right here is, okay, because that's my middle point, and then I would go up from there. So I want to know what that is. So what I'm going to do is I'm going to take 171 minus 11 minus negative 11, and that gives me from here to here is 182 days. Okay, I need to find the middle point because that's going to be from where it bottoms out to where it tops out. So from 182 days means divided by 2 gives me 91 days. So negative 11, so, or we can do 171 minus 91, and that will tell me what day this, oh, well, piece of trash, hang on. 171 minus 91 gives me 80 days. So 80 days into the year, I should be at the midway point. So my phase shift is minus 80. Okay, so now I need to put this mess together right here. So remember, we had a 2 pi over 365, and that's going to be x minus 80 days. Okay, so from there, I have 2 pi, or I've got 2 times 80 divided by 365, and I want, oh, piece of crap. 2 times 80 is 160. Divided by 365. Can you see what I'm doing? Math, enter, enter, gives me a ratio of 32/73. Okay, so what my final answer is my function is going to be an amplitude of 1.445 times the sine of 2 pi over 365 on x minus, and then I have distributed this, and I get 32/73. And then I went up 9.665. So up 9.665. Now there may be a little bit of a rounding error, just in case maybe we did 365 0.25 because of, you know, the whole leap year thing. But this is your general answer. Now, I would like to know, what is the number of hours of sunlight on June 5th? Okay, so I know what this is. Now I've got to figure out the number of hours of sunlight on June 5th, which means I need to figure out what number day of the year June 5th is. Okay, so June 5th is going to be, I don't know, 31 plus 28 plus 31 plus 30. So I get January, February, March, April, May, plus 5 days in June gives me 156. Okay, so I'm going to enter this entire thing in 156, using 156 for x. So I have 1.445 times the sine of, 2 pi over 365 times, what day are we on? What did I just say we were on? We were on day 156 minus 32 over 73. And then I add 9.665 to that. And I get 9.72 hours of daylight. So again, you may have some rounding error in there, but that is your essential hour, okay? Or that is your essential time. Depending on some rounding error, it should be 9.72 hours. So 32 over 73. Yes, I did. Okay, so that is the end of your final exam review.